In this video, we are going to create a mesh for a simplified aorta geometry. Some features of this geometry are it has tapering, so the diameter of the main vessel decreases along the aorta. It is including the upper branches, but they are modeled as simple cylinders, and it has a little bit of out-of-plane curvature to represent the real aorta case. So as I said, this is just a simplified model, but it can be useful for engineering applications. And before importing this geometry to ANSYS ICEM CFD, in Solidworks, I made some adjustments. These are, first of all, I created the blocking in Solidworks. This is our geometry, and let's hide this. So this is like a layout of the blocking I will create in ANSYS ICEM CFD. I did this because I want to store the exact coordinates of these points so that I will have a blocking in ICEM just as I want it. And I stored these coordinates in a simple Excel file. So I created some tables and stored all the point coordinates here. And finally, in Solidworks, I also cut the surface according to the guidelines of the blocking, so that in ICEM, when we import this model, it is going to be easier to associate the edges with the surface, with the actual geometry. So this is like a preparation in Solidworks. Now we are going to jump to ANSYS ICEM CFD. And we are back in our ANSYS interface, and I double click ICEM CFD and wait for it to open. Let's name it as our mesh. And again, double click model, and the ICEM interface will open up. This is our ICEM CFD interface. It looks quite old-fashioned, but it is very capable of creating nice structured grids. So I'm importing my file. So import model. Let's go to, and here I'm selecting all types. And I saved the file with a parasolid format, that is XT extension. That's how ICEM CFD can open files. I say open and apply. It is taking a while. Yeah. So this is our geometry. It doesn't look quite similar to what we saw in Solidworks. It is because this view is a simplified view. So from here, I can select. Let's go to geometry and hide curves. Everything will disappear, and open surfaces. We can do it in the wireframe mode or the solid mode. So we see our geometry here. And now let's again hide the surfaces and turn on curves. So these are the curves we imported from Solidworks. We will use these curves to associate the blocking edges to the actual geometry in a nice, smooth way. So as I said, I saved all these point coordinates in my drive so that I can transfer them to ANSYS ICEM CFD. And unfortunately, I could not find an easy way to transfer all the point coordinates. So what I'm doing is I will split my screen into two, and in ICEM, I'm going to select under geometry, select create point, and then I will select the XYZ option. And from here, I will just copy and paste the coordinates. This will take some time, I know, but this is how the process goes. Oops, a lot of points it just appeared in our model. So, okay, from points, right-clicking points and selecting blank points, we can select all visible points, and then they will just disappear. We hide these points because those points may sometimes be not in the correct position, and I want my points to be exactly where I want. So I will create my points manually, although it will take time. This will be a better option. So I copied the coordinates, I click apply, I see the point appearing here, and similarly again, all these are the same coordinates, just this. So I created these 4 points. This is the first section of my blocking. So for all these sections that we see with circles, this one, this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 sections. And also we got upper branches. I will copy and paste so that I can create points. I will keep doing this. Similarly, since this will take a lot of time, it actually will take around 15 minutes. I will pause the video here. And we are done with creating all the points. As we can see, all the points are in the exact positions that I want them to be. So the next step is creating the blocking. For that, I'm going to use the create block command. And I will select some of the entities, click apply. So a bounding block is created. I need to divide this to fit in the geometry. I will start by a rough blocking, then I will make it more detailed. First, let's create a horizontal cut and some vertical cuts. Okay, so I divided into 2 because there will be upper blocks for the upper branches, and the bottom blocks will construct the main vessel. We will see in a minute. First of all, I'd like to delete this block, this one. And now I will start to associate the edges with the blocks. I'm sorry, associate the points with the vertices so that the blocking will take the shape of the geometry. So I'm using the associate command, vertex to point association. So this will take some time. Let's start. So we see that the figure is trying to, the blocking is beginning to take the shape of the model. Okay. Let's make another cut. From here. I will delete this block in the middle. And snap this block to the second upper branch. This may seem like a little complicated operation, but by the time you get used to it, by the way, in the selection mode, I am using the control button. While holding the control button, you can move the model, but without it, you just basically select. There, I think I just made a mistake, so I will correct it. Yep. Okay. So one last cut for the upper branch. And we need to delete the blocks in between and the final one, not that. Yep. Okay, so this block will represent the upper branch that's associated with the upper branch points. That's right. Can use the undo command anytime you like. Okay, see, so our blocking just resembles the actual geometry, but not quite well yet. We need to perform a couple of more splitting to use all the points. This for here. And move this one here. Another 2 here. So I split the block again and associate these vertices with the related points. Okay. So as we can see, the blocking is now much better, and it represents the actual geometry. Let's just close curves and see how this resembles our geometry. I'm turning on the surfaces again. Oh, sorry, not surfaces, curves. And for the upper branches, I need to make a little cut again. Split block. Yep. And associate each vertex with the related point. And now we are done with the points association. The next step is associating the edges with the curves. So for example, let's start from here, associate edge to curve. These 4 edges, I select these and click the middle button so that it jumps to curves. Now it wants me to select curves. They will be associated to these curves. And from under blocking edges, when you say click show association, see this one is green and these edges are showing they are associated with this curve. So let's close this. And now I am going to perform this operation for every edge on our blocking. Okay, for example, this edge will be associated to this curve, this edge to this curve, and it will go on like this. For the sectional planes, I am using multiple edges and multiple curves at the same time. That is okay. Up to this point, let's make a check if we made any mistake. It looks okay. It's good for now. And if there's any problem with the associations, I will probably see it when you create the mesh in the final stage. It's just okay. Support. There was an error. I just closed ICEM and reopened it, and it's okay now. Let's continue. It's better this way to hide shells. So it changes the color. Let's again check the associations. Okay. As you noticed, the curves turn green when the association is complete. And we forgot these two. The final associations now. So all the edges are associated except these ones, and they will just snap onto the cylinders. Let's save our project, because sometimes the ISO can fail. So we are done with the blocking part, actually the association part. The next step is to create O-grid that is used for boundary mesh. So from under blocking, split block, and O-grid block. From here, I'm going to select faces. I want to select the normal faces to the geometry. In other words, the cross-sectional faces, starting with this inlet, this one, this one, the ones going to the upper branch, not that, not that as well. Okay, let's try from another point of view. Yep. Our next section, not this, not that. Let's do it like this, yes. And our next section, and the next upper branch. By the way, the right click button is backup, as it says here. It is very useful because I keep selecting wrong faces. Yep. And with the middle button, I click done and I click apply. And my O-grid is created. As I said, the faces I selected are the faces that I'm expecting the flow to be normal to, the perpendicular faces to the surface. So let's see what the O-grid block has done. It created, it divided all the blocks into 5 segments to create boundary mesh. See, it's a nice O-grid. It will allow me to use boundary mesh. Looks okay. It's better to check every time because the O-grid option may not always work as you want. I also have O-grid on the upper branches. This way, with the O-grid option, I will be able to generate a structured grid with most of the elements being hexa. So this looks okay. Yeah. Let's save the project because it's an important part. The next step is to adjust the meshing parameters. For that, I am going to pre-mesh parameters and select edge parameters. So with this, I will specify the number of nodes on each edge. And before, let's first select an edge. Let's select this inlet edge. It says the number of nodes is that is too low. Let's make it 10 for just visualization. And in the bottom, let's select copy parameters, and the method is to all parallel edges, so that as you can see, we will have a more smooth mesh this way, and it will be much easier to generate the mesh parameters, because otherwise you need to specify all the edges one by one. This option is important. And from here, I'm reactivating the selection tool. and select this edge. It is 2 by default. I'm making this 10 as well. So all parallel edges are copied. Again, from the select edge button, this edge, and as you can see, although these are not really parallel because those are 3D lines, it understands how the program understands which edges to copy the parameters. So this is a very useful feature. Let's make this like maybe 50. I don't know. It updated all the parallel edges, and again select this one. Let's make it like 30. This is, I don't know how this will turn out, but we are always able to recreate these numbers after we visualize the mesh. And for this edge, I will say maybe 15 and go on like this. 15 again. It's maybe a 10 because it's smaller. Let's make it 20. As I said, I'm making these numbers up. We will see how they turn up. Maybe I can make this one 30 because it is quite similar to this one, and that was 30. Anyway, yeah, we made this 50, and let's make this maybe 100. Are there any edges that we forgot? The upper branches, yes. Let's give this 50 as well. And the boundary mesh, for the boundary mesh, 2 is, let's make it 5. And later on, we will adjust the spacing so that the mesh is finer near the wall and gets closer towards the center. Let's check if I forgot any edge. Is it okay? These are all okay. Let's see this one, for example. Oh, that is 12. Let's make it 10. And these should also be 10 to be consistent. Yeah. The reason is, let's take this one. This is a square, and this is by default 10 because I adjusted it to be 10 all the way up here. So it is getting copied all the way to here. So I don't want like rectangular meshes, I want square meshes here. So I'm making this 10 as well. Okay, and these edges, I forgot. Let's make those 4. It is getting copied to all the necessary edges. In that way, ICEM is very smart because these 4 edges are obviously not parallel. But for now, it looks okay. I'm selecting dismiss. I adjusted almost everything, and now I am hiding curves, also hiding edges. Nothing is displayed, and I'm turning on pre-mesh option. It says, do you want to recompute? Of course, yes. And this is our mesh. To see it better, I'm switching to solid display. Yeah, so this is a quite coarse mesh because we selected this to be 10. But all in all, it looks not so bad. for the first iteration. Let's save it at this point and turn off pre-mesh and show edges. Because it was too coarse, I am going to change this edge parameter to maybe 20. If you're performing LES or even DNS, it will be much larger, of course. And it's down to 20 as well. And I shouldn't forget the upper branches. Dismiss, and let's recompute the mesh again. Disable edges and turn on pre-mesh. Recompute. Now it looks better. It's still coarse, but it's better. And as you can see, there are some sharp corners here. The mesh is not balanced between these two faces. So yeah, anyway, so as I said, this is just our first iteration. We can perform and play with the pre-mesh parameters to obtain a better looking mesh and a much finer mesh if you need. But for now, for the basics, this mesh looks okay. Yeah, and all the upper branches have the O-grid and they have boundary mesh. So for the details of the meshing parameters, that will depend on your geometry. And for this, I'm leaving it as is. So the final step is to export the mesh, but before doing, I will export the mesh for ANSYS Fluent, and also I am using OpenFOAM, the open source CFD software, and for that the ANSYS Fluent output with a .msh extension is useful. So for the Fluent extension, first I need to convert to unstructured mesh. It might say this, there's an already existing mesh, but we'd like to replace it. It is taking a while. Okay. So let's turn on surfaces. So our mesh is converted to unstructured grid. And to export it, we go to output mesh. And from this select solver, you can select your output solver. It is, there's many options. I'm selecting ANSYS Fluent, apply. And then I'm going to select this, before doing the export option, I need to create the named selections for the boundaries. For that, I'm right-clicking the parts and say create part. I select the inlet face. Sorry, the face, and name it as inlet. Why? I select the outlet and name it as outlet. And for the upper branches, I'm selecting this face and say branch 1, for example. These are also outlets. And this one is branch 2. And this is branch 3. So see, so it did not create the outlets. Let's do it again. So this is, I forgot to middle click, that is why. So let's undo it and again select the face and rename it branch 1 and select apply. Shows up here, and now this is branch 2, apply, and this is branch 3, apply. Okay, and I'm left with the vessel walls. Selecting all the surfaces. Yes, I selected all the faces on the outer wall. I'm naming them as walls. Click apply, dismiss. So I created the name selections for the inlet and outlet patches. And now I can export the mesh. It wants me to save it first. Let's save it. And at this point, we double click this ICEM.UNS and it brings an interface. It says grid dimension is 3D, yes, and there's no scaling. And I'm changing this write binary file to no, because in OpenFOAM you need to save the mesh in ASCII format, not binary. Then I'm clicking done. It is taking a while. Okay, so we exported. To find the exported file, I'm going to where I saved my project, and here it says the mesh is the project's name. I'm going into mesh files and into DP0, into ICM CFD, and here it says ICEM.msh. This is our mesh file. This one we can use in ANSYS Fluent, or I prefer it to use in OpenFOAM. So that was all for this tutorial. Thank you for listening. Hope to see you next time.